All right, so let's take a look here at this problem. We've got two rational expressions that we want to multiply together and get a single rational expression and to write it in lowest terms. And they also want us to state any restrictions. Restrictions in arithmetic come from the fact that we never want to divide by zero. The division by zero is undefined. Now, taking the square root of a negative number is also undefined, but since we don't have radicals here, we don't have any square roots, don't have to worry about that. But we do have variables in the denominator. So our denominators can never equal zero. All right, but let's start out by writing these two fractions as a single fraction by multiplying the two numerators together and multiplying the two denominators together. All right, so this binomial, it's easy to multiply by 1 because 1 is the multiplicative identity. When you multiply by 1, you get the identical thing back. All right, in the denominator, I have a minus 1 times this 16a cubed minus 80a squared. So it's a little bit difficult for me right now to see exactly what's going to cancel and how to write my restrictions because these binomials can be factored further. So let's do that. This 20a squared minus 100a. Let's write 20a squared as 20a times a. And let's write 100a as 20a times 5. And now you can see that a 20a is common to both terms. And I have 20a times a minus 5. All right, so let's look at this denominator, the 16a cubed minus 80a squared. Let's write this as 16a squared times a. Let's write 80a squared as 16a squared times 5, because 16 times 5 is 80, and we see that 16a squared is common to both terms. We can factor it out. What we have left is a minus 5. All right, so let's put that to action back in our fraction here. This numerator, we say factors to 20a. My 2's and my a's look a lot alike, so be careful. A minus 5. And in the denominator, I have this a minus 1. And this binomial factor to 16a squared times a minus 5. So now things are going to start happening because in the denominator, I can see exactly how to state my restrictions. I know that 1 minus 1 would give me a 0, and 0 times anything is 0, so I need to prevent a from equaling 1. Here I have a factor, a single factor of a. Well, 0 squared is 0, times 16 is 0, and 0 times anything is 0. So I need to prevent a from being 0. And in this binomial here, 5 minus 5 would give me 0. So I need to prevent, I don't want a to ever equal 5. Now, let's see what is common. The a minus 5 divided by a minus 5. And if I would have written this a squared as a times a, which I'm going to do it in the next. Let's continue. Let's look at the 20 and 16, and let's rewrite 20 as 4 times 5. And then I still have my a because I haven't canceled it yet. I've got a minus 1. 16 I'm going to write as 4 times 4. A squared I'm going to write as a times a. And that canceled, so that's all I have there. My restrictions were not equal to 1, 0, or 5. Now I can continue to see common factors. 4 divided by 4 cancels, and a single factor of a cancels. So in the numerator, all I have left is 5. And in the denominator, I have 4a, 4 times a, times this binomial, a minus 1. And since multiplication, we can multiply in any order, it's pretty common to write that 4a out in front. All right, and let's have a not equal to 1, 0, or 5. And there's our final answer. All right, well, I hope that helps, and I will talk to you later. Bye.